Start recording. Oh, I have it dark. Oh. Okay, 1.3. 1.3 is on geometry. My favorite subject, not, and literal equations. Yeah, geometry is definitely not my favorite subject, but this is okay, and I love teaching trig. But the geometry that you have to take in high school, not so much. What?
It was horrible.
Story. But what is a literal equation? Literal equation. Guess what? Formulas. Formulas are literally literal equations. Anything that has more than one variable. More than one variable. That is a literal equation. And in the second part of 1.3, we rearranging literal equations to whatever letter they tell us to do. So the first part of the geometry part is, let's talk about angles. How is an angle called that measures 90 degrees? A right angle, yes. So a right angle is, let me just write that down. Right angle 90 degrees. And a right angle looks like so. This would be your 90-degree angle. So now, if we're trying to add, or if we're trying to find the sum of two angles and it adds up to 90 degrees, these angles are called complementary angles. Ever heard the word complementary angles? Two angles. Angles are complementary if the sum of the two angles is 90 degrees. Two angles are what? Are called supplementary. If the sum of the two angles, who knows it, is, if the angles are supplementary, those two angles have to add up to what? 180 degrees. So 180 degrees is basically when you have a straight line and you kind of form two angles. These two angles, let's call it x and y. X plus y, they have to add up to 180 degrees. And these angles are called supplementary. Now, what do you know about the sum of all the angles in a triangle? All the angles, so let's say we have a triangle here. These are my angles. It's called triangle because we have three angles, and those three angles, they add up to what? Who knows it? 180. 180, because really what happens is, it's a rectangle here, it's a bad rectangle. But a rectangle, as you can clearly see, has 4 angles that are 90 degrees, so that's 360 degrees, the sum of a rectangle. Now, what did the powers to be back in the day who were discovering geometry? They cut the rectangle in half, and now we have 2 triangles. So 360 divided by 2 is 180, and that's how you got the sum of the angles. The sum of the angles in a triangle is 180 degrees as well, half of a rectangle. Okay, so let's do some angle problems first, and then we're going to look at some rectangle problem. On page, where are we? On page 32. Page 32, let's pick something like number 18. Number 18 says 2 angles are supplementary. Right off the bat, what do we know? We know that those 2 angles equal to 180. So you kind of can put your outer frame of your equation already down there. We have 2 angles, they are supplementary, that means they measure 180. One angle measures 12 degrees less than 3 times the other. But we can only use one variable. And that's why I've been telling you in chapter 3, we're actually allowed to use 2 variables. In chapter 3, this problem is probably a little bit easier as it is now. We only can use one variable. So we have to express both angles in terms of x. So that means the first angle, which one that is, we're going to give the x variable. One of these angles is just plain simple x. We know nothing about the other angle they're talking about here. One angle is 12 less than 3 times the other, so the other would be considered x. What do you know about the second angle now? If we call one x, then the second angle is based on our problem. 12 less than 3 times the other. 12 less than 3 times the other. How do we write that in terms of an algebraic expression? 12 less than 3 times the other. So then 3 times the other has to come first, 3x minus 12. With subtraction, the order is important. We cannot say 12 minus 3x. That is not the same as 12 subtracted from 3 times the other. That part has to come first. And these are our 2 angles that we're going to plug in here now. So x and 3x minus 12. That is your equation. And now it's kind of combined like terms. 4x minus 12 equals 180. Add 12. 4x equals 192. Divide by 4. Does anybody have a calculator? 48, my favorite number. $48. I'm going to go with it. Yes. 48 degrees. So one angle is 48 degrees. Again, if you stop here, you only get half credit because you got to find both angles. You can either do 180 minus 48, or you can do 3 times 48 minus 12. 3 times 48, 144. Minus 12, 132, right? 132 plus 48 indeed is 180 degrees. You can check yourself by adding the two angles here. How do you like that? I like it. Now, in the book, like number 19, this is kind of self-explanatory, or let's take a look at number 20. They kind of give you the picture here, and they say this is 2x plus 15 and 10x plus 36. So they give you the algebraic expressions already, and they give you the geometrical angle graph here. So what do? Solve for x and find find the measure of each angle. So what do we have to do here? What do we do with the two angles that are given to us? We add them. And what do they add to? 90 degrees. 10x plus 36 equals 2 times x, not equals, sorry, you said we add them, plus 2 times x plus 15 equals 90. Because that is a right angle here, both of these have to add up to 90 degrees. So you go ahead and solve this equation. Distribute the 2 plus 30 equals 90. Combine like terms. 10x and 2x is 12x. And 36 and 30 is 66 equals 90. Right? If we subtract 66, we get 624, right? 12x equals 24. Divide by 2, by 12, I already have the answer in mind. X equals 2. Now, problems like this are always on the test, and too many students stop right here because they think they're done. You found x, but you haven't found any angles yet. So what you have to do is now you have to go in here and plug it in. 10 times 2 plus 36. 20 plus 36 is 56. So one angle is 56 degrees. The other angle has to be what? 34. We did something wrong. So let's 2 plus 15 is 17 times 2 indeed is 34. We didn't do anything wrong. Here you go. So you have to go through the whole steps and then plug it back in to find the two angles. Do not stop here. Let's do one more with the triangles. I see fraction coming on, so that's always a good thing. Let's take a look at 16 on page 32. The smallest angle in a triangle is 1/2 the size of the largest. The middle angle measures 25 less than the largest. Okay, so here we got a label. So we have a small angle, we have a middle angle, and we have a large angle. All three of them have to be expressed in terms of x. Which one is x here? I hear people say the smallest. Does everybody agree with that? when you're reading something, you always have to give the x to the one you know absolutely nothing about.
I thought it's the largest.
You think the largest?
Because the smallest angle is 1/2.
The largest would be x.
Yes.
Because we know that
We
the
know-
1/2 of the largest in the middle is 25 less than the largest.
You are absolutely correct. Give me your name again.
Sarah.
Sarah, right. Sarah's absolutely correct. We know nothing about the largest. We know the smallest is 1/2. We know the middle one has something going on. But they're all compared to the largest. So the largest value is the largest angle is your x. So when you read these problems, not only do you have to read them 10 times, but also look for that. Okay, which one is the value? They give me nothing. They keep talking about the large, but I don't know what it is. The smallest angle, now we can express the smallest angle is 1/2 the size of the largest. So how would we represent the smallest angle now? 1/2 the size of the largest. And since we call the largest x, so then that's what it is. The middle one is 25 less than the largest. 25 less than the largest. No. 25 less means minus, and then the largest has to come first. X minus 25. Guys, okay? So now, what do we have a triangle, and we got to find those angles. So what do we do with all of them? How do we come up with our equation? Right, we add them up. 1/2 x plus x minus 25 plus x equals 180. That is the equation you need to solve. So I'm going to give you a minute or two. Go ahead and solve it. If you want to combine like terms first, you can do that. One half x plus x is 2x. What's 2x plus 1/2 x? 2.5 x. Yeah. Do I like mixed numbers? No. Or if you want to, you can multiply everything by 2 and clear the fraction. So we don't have to figure out what 2.5 is as an improper fraction. While you do that, I'm going to organize some of my pages here. Any answers? Let's hear it. Anybody? Yes.
So the small angle will be 44 degrees, the middle will be 57, and then the largest is 82.
You agree with that? Let's find out. Okay, so I'm going to keep the fraction for right now. So 2.5 is 5/2 x. I just combined all the x. Minus 25 equals 180. I'm going to add 20. Well, I always say clear the fraction. So I'm going to multiply everything by 2. 2. So that gives me 5x minus 50 equals 360. So this 2 reduces with that 2. And don't forget to multiply the 25 and the 180 by 2. So add 50. 5x equals 410. Divide by 5. So x is definitely 40 is 80. And 10 is 82. Yep. So x is 82, and I labeled x as the largest angle. So the largest angle indeed is 82 degrees. Then to find the middle angle, we just plug in 82 minus 25, and that is
I think it's 72.
what?
I think it's 72.
What's 72?
The largest angle.
410 divided by 5?
You need to multiply the 2 by minus 25. That's where you're getting that. I got the same thing at first.
Let me use my calculator. 410 divided by 5 is 82. How did you do it that you get 72?
No, I got you, man. When you distributed so when you multiply both sides by 2, like the 180 and the 5 were 2x minus 25, you forgot to multiply the 2 by minus 25. I
Yeah.
got the same answer
Yeah,
at first.
you need to multiply everything by 2, so don't forget the 25. Yeah. So 82 is correct. So that's 57 and 1/2 times 82 indeed is 41. So here you go. These are my 3 angles. Yep. If you would have, let's just say you didn't multiply by 2. Let me just show you. You had 5/2 x minus 25 equals 180. So you add the 25. 5/2 x equals what? 205. And if you're still not multiplying by 2, then you multiply or divide by, you multiply by the reciprocal, which is 2/5 times 2/5. Well, that's still 5 goes into 2/5, 41 times 2 is still 82. Either which way you slice it, dice it, comes up with 82. Okay, cool. What do you know about rectangles? What is the formula for the area of a rectangle? Base times height, or with rectangle we usually call it length times width. Base and height that are usually reserved for a triangle, where this is the base and here you have the height. The triangle uses base and height, the rectangle uses length and width, and while we're at it, the formula for the triangle area is 1/2 times base times height. 1/2 coming from that it's half a rectangle. Yes. Okay, So there's a word problem here. Number 7 on page 31. That deals with a volleyball court. Who plays volleyball? A volleyball court is twice as long as it is wide. Actually, they're not even talking about the perimeter. The area, they're talking about the perimeter. The perimeter, all 4 sides, or so let's call this LL, of course, opposite sides have to be the same. If you want to find a perimeter of a geometrical figure that is not round, that has angles, all you have to do is add your sides. So they are L plus W plus L plus W, so they are 2L plus 2W. That is the formula for the perimeter of a rectangle, because that's what we have here. A volleyball court is twice as long as it is wide. Let's just stop with the first sentence. Which variable do we know nothing about? The width or the height, the length? It is twice as long as it is wide. So the W, in this case, my width or wide, would be my x. The length is twice as long, that's 2x. So this rectangle, x, which one you make the length and the width, I don't really care, as long as you have it here twice. So it looks more or less like that. Actually, the other way around, but get the idea. The perimeter, P is given, that is 177 feet. Okay, now we have to find the length and the width of this volleyball court. All you really need to do is combine like terms. So if you look at my rectangle here, how many x's do I have? 2, 4, 5, 6. 6x. 6x all around. 2 plus 1 is 3, plus 2 is 5, plus 1 is 6. 6x. And that is equal to 177. Now we definitely need a calculator. 177 divided by 6 is 29.5. 29.5 feet. So that it is the width, that's how long it is wide. How long is it? 59 feet. 2 times 29.5 is 59. I wanted to do an area one. Where's an area one? They're all perimeters. Why do I have area on my mind? Perimeter. Every single one is a perimeter. Okay, perimeter it is. You want to do another one? Yeah, why not? How about number 9? No, too easy. Let's look at number 10. We have a triangular garden. Here you go, beautiful. Has sides that can be represented by 3 consecutive integers. If the perimeter is 15 feet, what are the lengths of the sides? So what did it say here? 3 consecutive integers. Okay. How do we set that up? The first side is what? We have 3 consecutive integers, so we have 3 sides. And when we look at the perimeter, we add up the sides. They have to be equal to 15. Now you have to come up with the sides, represent them in terms of x. One side has to be what? X. Thank you, guys. One side is x. Which side you make x, I do not care. The next side is what? X plus 1. It says 3 consecutive. And the third side is x plus 2. You do the rest of the story. What answers do I hear? 4, 5, and 6? 3x plus 3 equals 15 minus 3. 3x equals 12. Divide by 3. X, what? 4. So this side is 4 feet. The next consecutive number is 5 feet. And the third side is 6 feet. And if you add them all up, that better be 15. Otherwise, you did something wrong. Any questions here? Consecutive, supplementary angles, complementary angles. Okay, well, let's go on to literal equations then. Like I said, formulas, anything that has more than one variable. Now, since we didn't use the area of a rectangle, let's use it now. That is our formula for a rectangle. You don't really have to know all the formulas or the literal equations. But now we want to rearrange this for L. We want to solve this equation for L without having any values or numbers there. How do we get L by itself? Divide by, this is multiplication, so this is L times W, the W's got to go. And when you have multiplication, the brother of multiplication is division, or the sister. I always call them brother and sister. So we are dividing by whatever's not the letter L, and you only have one, which is a W. And you have to do that to both sides. Why can we do that? Because W over W, I know we always say, oh, they cancel, they go away. They do not go away. They reduce to 1. And the reason why I keep stressing this now, we get to chapter 5, we have to reduce, we cannot say cancel, because then you're getting all confused. So on the right-hand side, we have an L by itself, and the left-hand side is A over W, and guess what? Done you are. There you go. That's the first one. How about the triangle one? Since we talked about the triangle one, I said the formula for the area of a triangle is 1/2 times base times the height. And let's say I'm making this up, I want to solve for the base. How do you do that? What should be your first step? I would first of all multiply everything by 2, because we do have a fraction here and we want to clear both sides by 2. That leaves you on the left-hand side with a 2a, but on the right-hand side, the 2 reduces with this 2, and all you have left is b times h. So now again, it's kind of easy pickings. We divide by everything that's not a b, which is an h, and we're done. b equals 2a over h. Done. You are off you go. Next problem we do. They actually have the area rectangle 1 as number 31. How about number 34? We talked about perimeter of a triangle. Let's change to a whiteboard, why not? 34 is A plus B plus C equals P. And we want to solve for B. You're adding all 3 sides, so that's your perimeter of a triangle. How do you solve this one for B? Always ask yourself, what kind of original operation arithmetic is going on in the original? It's addition. So how do I bring it to the other side? Subtract. Subtract everything else that's not a B. So the A's got to go, and the C. The B's the only one you're not touching. What you do to one side, you do to the other side. So the A's here cancel, the C's cancel. You're left with B equals P minus A minus C. And that is it. Done. What else do we have? Number 37 is the conversion if you want to go from Fahrenheit to degrees Celsius. 9/5 Z. Well, these days, if I want to ask for a conversion, I just ask Alexa. Especially when I'm doing some cooking measurements, and Alexa, what is 180 degrees for the oven in Fahrenheit? And she tells me. What did we ever do without her? Okay, what are we solving for? For C. Celsius. Actually, if you have the book and look at number 38, that is the answer. They kept it as a distributive property, so they said, let's get rid of the 32 first. F minus 32 equals 9/5 C. And then instead of multiplying everything by 5, I mean, you can do that, but the official formula says let's just multiply by 5 over 9, the reciprocal, to both sides, and then we just keep it in distributive property form. C equals 5 over 9 times F minus 32. Why is that? Why don't they distribute? Because it's actually, the math is easier if you do the Fahrenheit. Like, for example, 77 degrees Fahrenheit, the Celsius is 25 degrees, so it's easier to do 77 minus 32. I always do that in my head, and then multiply by 5 and divide by 9. How about something we need for the next chapter when we talk about linear equation, slope-intercept form, y equals mx plus b, and the graphing straight lines, that's all should be, maybe you've heard of that. So if I look at number 52, negative 4x minus 5y equals 25. That is something you will see in chapter 2, and for example, I ask you to solve for y because I want to know what is the slope, not now, but in chapter 2, and what is the y-intercept. So we have to be able to learn how to solve these for y, and that's why we do it in chapter 1. There's a reason for everything. Okay, any ideas? You gotta solve for y. Yeah, but how? Okay. We want to, everything that doesn't deal with the y has to go to the other side. So that minus 4x has to go. And the only way it can go is by adding it. So don't forget there's a minus 5y. You have to bring the minus 5y down, and I want to get you used to chapter 2. So you can write 25 plus 4x, that wouldn't be wrong, but we want to write the x term first. So 4x plus 25, because that's how we do it in chapter 2. Now what? Divide everything by negative 5. And I would write it like this, because then I know I need to divide everything. That gives me a y on the negative 4/5 x minus 5. You got it. I'm going to put a circle around that one. Well, it's not a circle, it's an ellipse, but anyway. Speaking of circle, ellipse, who is going on all the way to calculus? Anybody? Calculus? You can admit it if you even... Engineering? No?
What was the question?
Nobody wants to be an engineer? Math. So here we go. 48, my favorite number. V equals, this is a formula for volume, 1/3 pi, Greek letter pi, 3.14, not the pie we eat. 1 year Pi Day was during school. Pi Day is usually during spring break. You know what Pi Day? That is the holiday for a math person like me. 314 is Pi Day. And one time it was during college school because spring break was earlier or later. And everybody brought a pie. I will never forget it. I think we ate 20 pies that day. So that's, of course, food, you know. Okay, what are we solving for? I got too excited about the pie. Thinking about food, we're solving for H. For H. See if I can draw, not good. We have the height, a soda can. We're looking for the volume. A soda can has two circles, so R is the radius, and here's the height, and that would be the formula for the cylinder. It's called a cylinder, soda can, for the volume. Okay, anyway, but that's beside the point. I do know some geometry if I want to. What's the first step? What would I do first if you were me? Get rid of the 3. Always clear the fraction first. 3, because this is all multiplication. So if I multiply, it's not like it's addition or distributive property. If I divide this 3 into this 3, it turns into 1, and done we are with the fraction. So we have left 3v equals pi times r squared times h. And now, again, we have to ask ourselves, what kind of operation originally in the red do I have? That's multiplication. So in order to move it, I have to divide it. And what am I dividing? Everything that doesn't look like an h. So I'm dividing the pi and the r squared all at the same time. On the other side, I'm dividing the pi and the r squared. So now these pi's are gone. We ate them. The radiuses are gone. They are not gone. They reduced to 1. And our final answer is 3v over pi r squared equals h. And we just rearranged our formula. And one for good measures, and then we're done. So we covered everything from chapter 1 now. Take a look at problems, homework problems on Friday. Have some problems ready for me, and I also have a review we do together, and then Monday is the test. This is a formula that comes from statistic, where you have to find a z-score for continuous variables. For example, if you want to find the probability of how many people are over 5 feet tall or something, we have to know z-score, but you will learn that. Now this z-score looks like so. It's, well, I'm just going to write it down. It's number 61. It's x minus, this is a Greek letter, don't worry about it. It's mu, if you must know. And this is another Greek letter that is called sigma. So x minus the mean, basically, in statistical language that you may have to take or not, x minus the mean divided by what is the standard deviation. And you have to solve this equation for x. In statistics, that x represents what we call a cutoff score. Like, what would be the cutoff score if you scored in the 97th percentile on your SAT scores? That kind of x, that's what that x represents. So how do we solve for x? We need to multiply. We got to get rid of, let me actually say x minus m over s. Here you go. And we want to solve for x. What is the first step? Again, you have a fraction, so you multiply by s over 1 or just s. So that is s times z equals x minus m. What is the last step to get x by itself? Add m. So that means x equals, let me write on the left-hand side, sz, the standard deviation times that z-score plus m. And that is, if you have to go into statistics, what is called finding the cutoff score for something. Okay, guys, that's it for today. I'm going to